Okay, the last functional group we'll consider in our series are aromatic substances, for which the most common one is benzene. So benzene is an example of an aromatic compound. An aromatic typically means that you're talking about rings containing alternating double bonds. It's a particularly stable rearrangement. Be aware that this is not long bond, short bond, long bond, short bond. They're all equivalent, meaning this is not a true representation of this substance. It's really halfway in between a single and a double bond throughout. This can be shown by having each double bond be 1.5 bonds with a dot, as are these. So they all have a bond order of 1.5. And chemists typically don't show it that way. They say, well, it's halfway between this molecule and another molecule where you just alternate the double bonds, and you can show what they call a resonance interaction, which means it's really halfway between those two substances. Having these, at least formal, double bonds, they're nucleophilic there. They're electron rich, and they can swing out and attack something. It requires a certain amount of energy, and you need to have a good electrophile, hopefully something with a nice formal positive charge, since it doesn't give up this stabilized form very easily. But the typical reaction is known as electrophilic substitution, or if you will, electrophilic aromatic substitution. And this is the mechanism for which it goes. Let's start by making this nitric acid a better leaving group. Turn it into NO2+. That can happen if you just have an acid present. It'll protonate that oxygen. See that right there? You could begin by saying H plus being attacked by the lone pair of electrons on that hydrogen, which then renders it as a pretty good leaving group. So you lose that water molecule, it regains its lone pair of electrons, and you have NO2 plus as a nice strong electrophile. Sufficiently strong that if you heat it up, it will nitrate this substance, right? It'll just form an NO2 group. This would be mononitrobenzene. Heat it up some more, you can get some dinitrobenzene. Heat it up some more, you can get some trinitrobenzene. And if you have a methyl group right there, that happens to be called trinitrotoluene, which is a shock-sensitive explosion and just a bad customer. Anyhow, that's the mechanism. This lone pair of electrons will come out and attack that positive charge, but that'll give you a secondary carbocation, which doesn't look great, but it is what they say resonance stabilized. We can show different interactions. For instance, if you take that double bond, just swing it over there like that arrow implies, that spreads the charge out to here. You can also show it here spreading out to there. And so it's a resonance stabilized secondary carbocation. It can then finally regain its ring by just the loss of H+. Now you have an uncharged substance, a water molecule. That H plus can catalyze the next reaction to make some more NO2 plus, rendering it catalytic with respect to hydrogen, and this can make nitrobenzene. So that's the one reaction we'll consider for aromatic substances, electrophilic aromatic substitution in the form of nitration. If you don't like that NO2 group and you want to reduce it down to an amine, you can. Tin is a good reducing agent, and it will probably form tin oxide, right? It itself gets oxidized, and this will, in the presence of acid, will give you the protonated amine. Now be aware that anytime you have this quaternary amine here, we call these quaternary ammonium salts, and they become water soluble. These would go into a water layer and can be removed from the other greasy substances very easily. Water insoluble, water soluble. But perhaps you'd prefer it as what they call a free base, not as a charged substance, but as just a plain old organic substance. This would be called aniline. Well, we just add some base, some hydroxide, and we can then lose that molecule of water by deprotonating this thing, and there it is in the form of what they call the free base. Now it's an organic substance, not a salt, and this would be aminobenzene, also known as aniline. This is an introduction to benzene and aromatic compounds in general.